In our last video, we established the structure and language of ratios. In this video, we are going to explore some of the basic principles that make ratios so useful, and we are going to use a situation that many of us can relate to, sharing a box of donuts. If we have 4 donuts and split them between 4 people, each person will get 1 donut. If we have 6 donuts and split them between 6 people, everyone still gets 1 donut. This is true any time that you have the same value in the numerator and the denominator. 458 donuts for 458 people, 1 donut each. X minus 7 donuts for X minus 7 people, 1 donut each. And this will work for anything that can be written as a ratio. So all of these fractions equal the same thing. Let's go back to our first example, where 4 people were sharing 4 donuts. If we double the number of donuts but keep the number of people the same, now each person gets 2 donuts. If we triple the number of donuts, each person gets 3 donuts. Anytime we multiply by a whole number, we change the number of donuts, aka the numerator. But the denominator is not affected. So if I had the ratio 3 over 2 and multiplied by 3, the numerator becomes 3 times 3, while the denominator stays the same. If we evaluate this, we get 9 over 2. This also means that we can rewrite something like 3x over 2 as 3 over 2 times x by factoring x out of the numerator. Now let's look at what happens when we change both numbers. If we start with 4 people sharing 2 donuts, each person gets half of a donut. Then, if we multiply both numbers by 2, 8 people are sharing 4 donuts, and everyone still has half of a donut. If we divide both numbers by 4, then 2 people will be sharing 1 donut, so each one gets half of the donut. If we multiply or divide the numerator and denominator by the same value, the ratio stays the same even though the individual numbers have changed. We call these ratios equivalent ratios. Say we start with the ratio 9 over 6. We could find an equivalent ratio by multiplying the numerator and denominator by 4, giving us an equivalent ratio of 36 over 24. When we simplify a ratio, we're trying to find an equivalent ratio where the numerator and denominator could not be divided by the same number. If we wanted to simplify the ratio 9 over 6, we would divide the numerator and denominator by 3 to get an equivalent ratio of 3 over 2. 3 and 2 are not divisible by anything other than 1, so the ratio is simplified. Now, all of our examples so far have assumed that we want to share the box of donuts, but that's not always the case. So if you have 2 donuts and you eat both of them, then the ratio is 2 donuts per person. 5 donuts just for you, 5 donuts per person. 3x donuts just for you, 3x donuts per person. No matter how many donuts you have, if you are the only one eating them, then the ratio is just the number of donuts that you started with per person. This shows us that any fraction with a denominator of 1 is equal to the numerator by itself. These rules will help us as we work with rates and fractions in complex equations and inequalities. In this video, we covered the basic principles of ratios and how they work.